On behalf of the SCSTE, I would like to welcome all viewers and especially our dear students, and I hope that you will gain a lot of benefit from this program. And today I'll be doing the continuation on the chapter Introduction to Trigonometry. Let's begin. So, in the previous online class, we have learned about the concept of trigonometry, angles, and the 6 trigonometric ratios with respect to acute angles. But those acute angles which we have learned are acute angles which are in general, right? So now, on this class, we will learn about the trigonometric ratios with respect to some specific angles. And these specific angles are 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Alright, so I've already drawn this table for you, and this table shows us the different trigonometric ratios of sine, cos, tan, cosec, sec, and cot with respect to these specific angles. Alright, so now looking at this table, you may be wondering how you can remember all of these, right? It seems a little bit difficult to remember all of these by heart, but actually you don't have to learn this table by heart. You can draw this table, you can produce it again without memorizing by heart, and there's a method to do that. Alright, so now we'll go into that method. So first of all, in this method, we try to produce the trigonometric ratios of sine. Alright, after producing the trigonometric ratios of sine, then you can produce all these trigonometric ratios very easily. Alright, so to produce the trigonometric ratios of sine, first of all, you write down these numbers 0, 1, 2, 3, and 4. Alright, this is the first step. The next step is to divide each number by 4. So we divide each number by 4. So after dividing, you simplify. Alright, so if you divide 0 by 4, you get 0. So divide 1 by 4, we just leave 1 by 4. Alright, we'll not write it in decimal form. You can cancel 2 by 4, so you get 1 by 2. 3 by 4, you just leave it as it is, and 4 by 4 you get 1. Now the next step is to take the square root of these numbers. Alright, so let's take the square root of 0. We take the square root of 1 by 4. We take the square root of 1 by 2. We take the square root of 3 by 4. And we take the square root of 1. So next step is to simplify. So if you take the square root of 0, you get 0. If you take the square root of 1 by 4, you get 1 by 2. If you take the square root of root 1 by 2, you can split the square root. Alright, you can write it like this: root 1 by root 2. So root 1 you get 1, root 2 you just leave it as it is. Now we can take the square root of root 3 by 4. So you get root 3 by 2. And if you take the square root of 1, you get 1. Alright, so we can see that we have obtained the trigonometric ratios of sine with respect to these specific angles. Alright, now we'll try to produce the trigonometric ratios of cos. To produce the trigonometric ratios of cos, you just have to write back the trigonometric ratios of sine, but in the reverse order. Alright, so to get the trigonometric ratios of cos, you just write the trigonometric ratios of sine in the reverse order. So since we are writing in the reverse order, and since 1 comes last, so it means for cos, 1 will come first. Alright, root 3 by 2 comes second last, so for cos, root 3 by 2 will come second. 1 by root 2 is in the middle, so it remains the same. So 1 by 2 is second, so that means for cos it will be second last. And since 0 is for the trigonometric ratio for sine, 0 is the first one, so for cos it will be the last one. Alright, so we have obtained the trigonometric ratios of cos. Alright, now we try to produce the trigonometric ratios of tan. To get the trigonometric ratios of tan, we have to use a relation. Remember this relation, right? We have done this in the last class. Tan theta is equal to sine of theta by cos of theta. So that means tan of 0 degree will be sine 0 degree by cos 0 degree. Alright, so let me just explain to you from the table. That means tan of 0 degree will be sine 0 by cos 0. That means we'll have to divide 0 by 1. So if you divide 0 by 1, you get 0, right? So that means tan 30 will be sine 30 by cos 30.
if you divide 1 by 2 divided by root 3 by 2, you'll get 1 by root 3. Alright? So if you find out for tan 45, tan 45 will be, according to that relation, sine 45 by cos 45. So that means you divide 1 by root 2 by 1 by root 2. So you'll get 1. And now we find out tan 60. Tan 60 will be sine 60 by cos 60. So it will be root 3 by 2 divided by 1 by 2. So you'll get root 3. Now for tan 90 degree, tan 90 will be sine 90 by cos 90, which means we have to divide 1 by 0. And that, remember, we cannot divide by 0, so we write undefined. Alright, because division by 0 is not allowed. So now, to get the trigonometric ratios of cosec theta, we have to use a relation again. Alright, we have to use this relation. Cosec theta is equal to 1 by sine theta. Alright, so to get the trigonometric ratios of cosec theta, we just divide 1 by sine theta according to that relation. Alright, so that means cosec 0 will be 1 by sine 0. So 1 by 0 is not allowed. Division by 0 is not allowed. So that means we just write undefined. Alright. So now for cosec 30, if you divide 1 by 2, you'll get 2. For 45, if you divide 1 by root 2, you'll get only root 2. For 60, if you divide 1 by root 3 by 2, you'll get 2 by root 3. It's just the inverse, alright. And so for 90 degree, it will be 1 by 1. So you'll get 1. Alright. So for sec theta, we have to use another relation. Alright. Let me write down the relation. Sec theta is equal to 1 by cos theta. So in simple terms, you just inverse these trigonometric ratios of cos. Alright. So 1 by 1 will be 1. So root 3 by 2, if you inverse, you get 2 by root 3. Alright. Take the reciprocal. Alright, so if you take the reciprocal of 1 by root 2, you'll get root 2. Take the reciprocal of 1 by 2, you'll get 2. And if you take the reciprocal of 0, it will be undefined because division by 0 again is not allowed. Alright, so now, to get the trigonometric ratios of cot theta, so we have to use a relation again. There are two relations for to get the trigonometric ratios of cot. You can either use this relation, cot theta is equal to 1 by tan theta, or you can use this relation. Cot theta is equal to sine theta by cos of theta. Alright, so let me just use this relation. It's more simple this way. You just have to take the reciprocal of the trigonometric ratios of tan. Alright. So if you take the reciprocal of this, you get undefined because division by 0 is not allowed. So take the reciprocal of 1 by root 3, you get root 3. Of 1, you get 1. Of root 3, you get 1 by root 3. And undefined, that means it must be like this. 1 by 0 or 2 by 0, alright? So that means we will have 0. Alright, means because when we write 1 by 0, we just say this undefined, so that means if you take the reciprocal, you just get 0. It may be 0 by 2 or 0 by 3, but still you get the result to be 0. So that's why we just write 0. Alright. So now using the knowledge of these trigonometric ratios, we will solve some problems from the next exercise, alright, which is exercise 8b. So from exercise 8b, we'll do the second question. And from the second question, we'll do question number 1. Alright, and in this question, we have to evaluate this value. Sine square 30 degree plus sine square 45 degree plus sine square 60 degree. So from this table we have already learned that sine 30 degree is 1 by 2. So we just substitute, alright. So let me just copy down. Plus sine square 45 plus sine square 60. So according to this table, sine 30 is 1 by 2. So that means we write 1 by 2. But it's not just 1 by 2. This is sine square 30 degrees. So that means we have to square 1 by 2. Because sine square 30 degree can also be written as sine 30 degree whole thing square. Alright, it's the same thing. So that means we have to square 1 by 2. So there's an addition sign, so we just put an addition sign. So now it's sine square 45 degrees. So according to this table, sine 45 degree is 1 by root 2. So we just substitute 1 by root 2. Since there's a square, so we have to square. There's an addition sign, so we put an addition sign. So now we have to move to sine square 60 degree. And sine 60 degree is root 3 by 2. So we just replace sine 60 by root 3 by 2. Since there's a square, so we put a square. Alright. So now we just need to simplify this term. Alright. So if you square 1, you get 1. If you square 2, you get 4. Because 1 by 2 whole thing square can be written as 1 square by 2 square. Alright. So there's an addition sign. So let me just put that sign. Now if you square 1, you get 1. If you square root 2, you get 2. Because this square and the square root gets cancelled. Alright. So now if you square root 3, you get 3. If you square 2, you get 4. Alright. So now you clearly see that the LCM is 4. So we just write the LCM. Now we have to divide this LCM by these denominators. Alright, by each of these denominators. So first we divide by this denominator and the quotient will be 1. So that quotient you have to multiply with this numerator. So you will get again 1. So there's an addition sign. So let me just put that sign. Now we have to divide this LCM by this numerator, by this denominator. So if we divide this LCM by this denominator, the quotient will be 2. And that quotient 2 we have to multiply with this numerator, which is 1. So you get 2. Now there's an addition sign. So we divide this LCM by this denominator, the quotient will be 1. So 1 you multiply with this numerator, which is 3, so you get 3. So if we add these terms, you get 3 plus 2, which is 5, plus 1, which is 6. So if you simplify, you just get 3 by 2, which is the required answer. Alright. So now let's move on to another question, which is question number 11. Alright. And in question number 11, we have to find the value of x. Right? The question tells us that we have to find the value of x where x lies between 0 degree and 90 degrees. Since x is less than 90 degrees, so that means x must be an acute angle. Alright? So we have to find x from this equation, which is given to us. Cos x minus sin x by cos x plus sin x, which is equal to 1 minus root 3 by 1 plus root 3. So it's very clear that first of all we have to cross multiply. Alright, so let's cross multiply. You don't need to draw these arrows in the exam, alright? This is just to make it clear, alright? So we plus 1 plus root 3 to the left side. So it will be cos x minus sin x into 1 plus root 3. Now we plus cos x plus sin x to the right side. So we get cos x plus sin x into 1 minus root 3. Now first of all, you have to multiply this term with these two terms. Alright, then after that, you multiply this term with these two terms. Alright, so first of all, you multiply the signs. So since there's no sign here, that means it must be plus. So plus into plus, you get plus. Cos x into 1, you get cos x. So plus into plus, you get again plus. Cos x into root 3, we write it as root 3 cos x. So we finish multiplying this term with these two terms. Now we multiply this term with these two terms. Alright. So first of all, we multiply the signs. So minus into plus, you get minus. Sin x into 1, you get sin x. So minus into plus, you get again minus. Sin x into root 3, you get root 3 sin x. So for this side, let me just write here. Now we multiply cos x and 1. So plus into plus you get plus, cos x into 1 you get cos x. So plus into minus you get minus, cos x into root 3 will be root 3 cos x. Now we multiply this term with these two terms. Plus into plus you get plus, sin x into 1 you get sin x. Now plus into minus you get minus, sin x into root 3 you get root 3 sin x. So now we try to get rid of terms which are the same, alright? So we see cos x and cos x here, so let me just explain to you, alright? So from this side we just subtract cos x, and from this side also we subtract cos x, alright? So the equation does not get changed because it's balanced, right? Because we're subtracting cos x on the left side and on the right side, so the equation does not change. So now again we can, now we can try to get rid of this minus root 3 sin x, alright? Because there are two minus root 3 sin x, one on the left side and one on the right side. So we just add plus root 3 sin x on the left side. So to balance this equation we have to add plus root 3 sin x also on the right side, so the equation does not get changed. Now we can cancel out minus cos x and plus cos x because they are the same values but opposite in sign, so we can cancel out. So now we can cancel out plus root 3 sin x and minus root 3 sin x. On this side also we can cancel cos x and minus cos x, plus root 3 sin x and minus root 3 sin x. Alright, so now we are left out with root 3 cos x, root 3 cos x minus sin x, which is equal to minus root 3 cos x plus sin x. So now we bring these two terms, right? We bring these two terms to the left side. How? By just adding, alright? We'll add these two terms with opposite signs. Root 3 cos x minus sin x, alright? We'll add this term but opposite in sign. So we'll add plus root 3 cos x and we'll add minus sin x. So to balance this equation, alright, we'll have to add this same term on the right hand side. So if you add this term, alright, these two terms on the right hand side, they will cancel out each other, alright? So you will get 0 on the right hand side, alright? So let me continue from here. So now we see that these two terms are like terms, so we can add them. Root 3 cos x and root 3 cos x, so we'll get 2 root 3 cos x, and minus sin x and minus sin x also are like terms, so we can add them. So we get minus 2 sin x, which is equal to 0. Alright? Now we can take common. The common term is 2. So 2 into root 3 cos x, you get back 2 root 3 cos x, alright? So plus into plus, you get back the same sign, which is plus. Now, plus into which sign here, you get minus, plus into minus. 2 into sin x, you get back 2 sin x. Now, you just divide both sides by 2, alright? If you divide both sides by 2, then this 2 and this 2 will get cancelled out, and then you get 0 by 2, and 0 by 2 is again 0. Alright? So let me continue from here. Now this 2 and this 2 gets cancelled out, so we'll get 1, 1 into this whole thing, we get again this whole thing, which is root 3 cos x minus sin x, which is equal to 0. Now I'll just add sin x both sides, alright? because I'm trying to bring all terms which contains x only on one side, and all the other terms I'll try to put it on the other side. Alright. So let me just add sine x. So we clearly see that the equation is still balanced because we have added sine x on both sides. So minus sine x and plus sine x, you get 0. So you get only root 3 cos x, and you get sine x. Now I'll divide both sides by cos x. Alright, this is possible because it's given in the question that x is less than 90 degree. If it's not given that x is less than 90 degree, which means that if x also can take the value 90, then we cannot divide both sides by cos x, because cos 90 will be 0, right? According to this table, we see that cos of 90 is 0 and division by 0 is not allowed. But since x is given in the equation to be less than 90, so that means we can divide both sides by cos x. So if we divide both sides by cos x, then this cos x and this cos x will get cancelled out, and we'll have sine x by cos x. Let me continue from here. So now on the left side we are left with root 3, and on the right side we have tan x, because we have from that relation, remember, tan of theta is equal to sine of theta by cos of theta. So that means sine x by cos x will be tan x. So root 3 from the table, we see that it is tan of 60 degree. Alright, so in place of root 3 we can write tan of 60 degree, which is equal to tan of x. But we clearly see that as x is given to be lying between 0 degree and 90 degree, so that means from the table this x, alright, which means this angle x must be 60 degree. Alright, so that means implies you can write 60 degree is equal to x, which is a required answer. So now I'll be stopping here for this class, and in the next online class we'll be doing a theorem, and from that theorem we will obtain some relations between the trigonometric ratios of complementary angles. Right? Now we have done trigonometric ratios with respect to some specific angles, and in the next class we will do trigonometric ratios, alright, between complementary angles. Thank you.